Okay, now rotational dynamics, the second questions. Refer to figure above. The radius of the pulley is 5 cm. Object B is released from rest and travels 2 meters in 1 second. The pulley rotates without slipping. Determine the moment of inertia of the pulley about the axis of rotation. Okay, so we have the radius of the pulley. All right, okay, the radius of the pulley, which is the R. Okay, released from rest, travels 2 meters in 1 second. So put in information for block B. What happened to block B over here? Actually, this one can help us find the acceleration. Okay, can help us find the acceleration. We just use the kinematic equation. We can find the acceleration. Well, let's just find the acceleration. It help to ease our job. B is released from rest, travels 2 meters in 1 second. So, this thing will accelerate downwards. Yeah, accelerate downward. So start with initial velocity 0, travel downwards -2 meters, 1 second. So let us find the acceleration. Okay. So displacement is -2 meters downwards. So 0 velocity, and then acceleration 1 second. So what is our acceleration? Our acceleration we get is let us find it out. Yeah, let's find out. So our acceleration we get is -4 meter per second square. Okay. Yeah, so that is negative. It just means the direction downward. Yeah, it means direction downward. Okay. But actually we don't need the negative. We can we want the magnitude only. The magnitude of acceleration is just 4. Okay, I can ignore the negative sign. Yeah, I just want the value, which is 4. Okay, I got the acceleration. Good. Now the question asks for moment of inertia of the pulley. So I want to get the moment inertia of this pulley. First of all, if I want to do this question, I must draw free body diagram. Okay, free body diagram. So on the block A, it has the weight downward, weight A. It has the tension. Tension I put as tension 1. Here got 2 string. This time the tension for string A and string B different. Why different? Because we consider the pulley. Pulley now is also rotating. Pulley now is also rotating with angular acceleration. So the tension for tension 1 and tension 2 now different. If you don't consider the rotational motion of pulley, then tension 1 and tension 2 they are equal. Okay, but now because we consider the pulley, the tension 1, tension 2 different. Okay. So these two forces act on the block A. So what force act on the block B? Let's consider block B first. So block B, it has the weight downward. It also has the string pulling upward, tension 2. Okay, that's about block B. Now how about pulley? Pulley, tension 1 pulling downward at the left hand side. For the right hand side, you have tension 2 pulling downward. Okay, they must exist in pairs. Tension 2 has a pairs. Tension 1 also has a pairs. Tension 1, this tension 1 act at block A. This tension 1 act at the pulley. This tension 2 act at block B. This tension 2 is pulling at the pulley. Okay, that's how is it. And then don't forget, this pulley also hanging. So if the pulley itself also has the weight of weight of the pulley and support. It is supported by the cable, so has a support force. Okay, S. Let's put like that. So we have finished. Okay, don't forget. The acceleration. Sorry. Okay. Okay, again. Yeah. So don't forget we have the, you know, this one has accelerate downward. This object will accelerate upward, and this one will rotate clockwise. Okay, and you can put all the sign going down positive, acceleration. This follow acceleration positive, opposite acceleration negative. Follow acceleration positive, opposite acceleration negative, follow acceleration positive, negative, follow acceleration positive, opposite acceleration negative. So this positive negative is to help us to find the positive or negative force or positive or negative torque. Okay. Okay, I redraw the diagram over here. So this is the diagram actually. I draw here. All right, we have all the required information here. You see, positive follow acceleration, negative opposite acceleration. Follow angular acceleration positive, opposite angular acceleration is negative. Okay, now let us start with block A. Start with block A. We do separately. When you have three objects, now in the past we just learned about the block. We don't consider the pulley. So we just consider block A and block B, two objects, two free body diagram. But this time in chapter rotational motion of rigid body, we also consider the pulley. So now we have three objects. Sorry, we have three objects to consider. So three objects, three free body diagram, and do it separately. Okay, so that's why we have block A. We do block A. We do block B, and then we also at the last we do pulley. This is the new one. Total torque equal to I alpha. Let us start with the simple one first. Total force equal to MA that we have learned before. Okay, the block A is tension going up, weight going down. So it's the same. I just redraw again here. So follow acceleration is positive. Follow acceleration is positive. So the tension one is positive. The weight A is negative because opposite acceleration. So let's write it down. So tension 1 is positive because follow acceleration. Weight A is negative because opposite acceleration. Equal to MAA. So what is the mass of block A? Mass of block A given, okay, 1 kilogram. Okay, I should write here. This is 1 kilogram for block A and 3 kilogram for block B. Let's write it down. Write all the information here. It's good because it becomes systematic. Your work becomes systematic. So 1 kilogram block A and 3 kilogram block B. Good. Now, okay, so let's fill in the values. So weight A is actually 1 g mg. Yeah, W equal to mg. The mass is 1 kilogram. Yeah, 1 kilogram. Okay, so can I get answer? You see, this acceleration I already get at the earlier part because the block B give us the acceleration that we calculated just now. Yeah, using kinematic equation. So don't use the negative sign. I just want the magnitude. So just ignore the negative sign, modulus it. I just want the magnitude, the 4. So this acceleration 4 is the same for both. You know, I mean, if block B accelerate downward with, if the block B is accelerate downward with 4, of course the block A accelerate with 4 also. You see, I don't put the negative sign. Why? Because I just want the magnitude 4. Why? Because we have a block going up, block going down. If you put negative here, negative 4, then this one become negative of negative 4. So then the equation become messy, become messy. So just ignore the negative sign, just put 4, the magnitude 4. We follow a new system, follow acceleration positive, opposite acceleration negative. We follow a new system already. Okay? Okay. By the way, I just want to say that if block B accelerate downward with 4, block A accelerate upward with 4 also. isn't it? They're moving together. They have same acceleration, and this alpha actually is A over R, because why? Because A equal to R alpha. Alpha is A over R, isn't it? A over R. So since we got A is 4, so 4 over R, isn't it? And R, we already got the R. We have the radius 5 cm. So we just put the radius 5 cm here. Yeah, we just put this radius 5 cm, which is 0.05 meter. We can get the alpha, isn't it? Very easy. Yeah, we can get alpha. So we can do the question. So simple. Okay, now let's continue with okay, we got the block A, but block A also accelerate with the same acceleration as block B, 4. So just put in the 4. Just put in the 4. So our tension 1 is equal to A plus G, you know, which is yeah lah, A plus G. So A is 4 plus 9.81. So what is our tension 1? Yes, 13.81 Newton. That's our answer. Okay, now let's do block B. Block B is have 3G tension, 2 and A going downward. So and mass of B is 3 kg. So okay, what force is positive? Yeah, follow acceleration, WB. Follow acceleration, WB positive. Sorry, follow acceleration is follow acceleration is positive, WB. Now opposite acceleration is tension, negative. Yeah, opposite acceleration, negative, tension. So equal to mass of B, mass of BA. Okay, so this is 3G, mg, Wmg. And then mass of B is 3. So tension 2. So just substitute, you know. So sorry. So 3. Okay. So just go and then 3G and then minus 3A, isn't it? Minus 3A. So we got the answer. A is actually what value? Yeah. A is actually negative 3. A is 4. Yeah, A is 4 just now. So what answer would you get for tension 2? So for tension 2 is 17.4, sorry, 0.4. Oh, something wrong, yeah? Okay, 0.43 Newton. That's our tension 2. That's our tension 2. Okay? Okay, so what's next? We have the tension 1 and tension 2. Now let's do the hard one, the pulley. The pulley, where's the axis of rotation? The axis of rotation is at the center. Okay, at the center. So at the center here, axis of rotation. So that's why the weight and the support force has 0 torque. The torque for weight and the torque for S, which is you know, is equal to 0. Why? Because based on the formula Fr sin theta, their R is 0. You know, axis again, axis of rotation. The S going up and the S act at the axis of rotation, cannot turn the object. The weight pulling down also act at the axis of rotation, cannot rotate the object. So the only force that rotate the object is tension 1 and tension 2. Tension 1 attract this way. You see the thing at rotate which direction? Pulling down, rotate anti-clockwise. It rotate anti-clockwise, and tension 2 rotate clockwise. You see, it rotate clockwise. It rotate clockwise. So again, so we have so we can say this can be neglected already. So only the tension 1 and tension 2 provide the torque. So which one is positive? So this torque, T2 torque, the torque for T2 is positive because the acceleration is clockwise. Yeah. So acceleration in this way follow acceleration is positive. So this torque follow acceleration positive. This torque opposite the acceleration negative. That's it. Okay. And they are both 90 degree. Okay. So can just multiply. They are sine 90. Okay, let's continue. So T2 is positive. So T2 is positive. T2 times R. The distance of the force from the axis of rotation is R. And then T1 is negative. T1 is negative because the torque is opposite acceleration. So negative T1 R. Okay, they are both sine 90. They are both we can say sine 90. So they are, just ignore equal to 0. No need to write the sine 90 also. Yeah. So okay. So what is the I? I got the I just now, isn't it? Right. Oh, I need to find the I. Yes, I need to find the I. I don't have the I need to find the I. But alpha, yes, alpha. I got the A. I speak earlier just now, right? Alpha is A over R, 4 over R. So, use this formula. I got the A, which is 4 already, just now. So, alpha is equal to A is 4. Radius is what? Radius is 5 cm. 5 cm is 0.05 meter. Okay? 0.05 meter. So what is my alpha? My alpha is what is my alpha? Never mind. So just substitute alpha with 4 over 0.05. Okay? So and then what's my tension 2? Tension 2 is 17.43. 17.43. R is 0.05. Same thing, 0.05. And then negative tension 1 is 13.81. 13.81. Also the R is 0.05. Equal to I for 0.05. So what's the final answer? My I is 2.26 exponent negative 3. The unit for I is kilogram meter square. Okay, why is it kilogram meter square? Because I is actually, the general formula for I is mr square. Kilogram, mass is kilogram, R is meter. So kilogram meter square. Okay, so that's our answer, 2.26 exponent negative 3. Moment of inertia for the pulley. Is it correct? Yes, 2.26 exponent negative 3 kilogram meter square. That's the pulley. Okay, so very simple. So remember, you just do the free body diagram, do it separately. For the block, you apply total F equal to MA. Okay, and the positive and negative sign, very important. Positive is follow acceleration, negative opposite acceleration. So the force that same direction with acceleration is positive. Opposite the acceleration is negative. Okay, and this one pulley also angular acceleration. If angular acceleration is clockwise, then the clockwise direction is positive. Opposite the angular acceleration, which is anti-clockwise, is negative. So the torque which rotate clockwise become positive because it follow the angular acceleration. The torque which rotate the object anti-clockwise is negative because it is opposite the angular acceleration. Okay? Total torque equal to I alpha. And the alpha can only always change. The alpha can always change to A over R. Once we got A, we can get alpha. Very simple, right? And the unit for I is kilogram meter square. So I hope you really enjoy this video. So please like and subscribe. Stay tuned for the next upcoming videos. Bye bye.